Hello, A-level mathematicians. I've discovered a couple of things that are really helpful when you're doing questions that involve differentiation when you've got your calculator. Okay, so first of all, we want to find the equation of a tangent and a normal to a curve. Okay, so I'm going to go to the graph menu and I'm typing in the curve. So y is x minus 1 cubed. I'm going to draw that. I'm just going to make sure, so by using view window, I want a nice square grid so that if I've got, I'm going to make it square to the x base. So if I've got a tangent and a normal, then that means I can see they're perpendicular to each other. So we'll draw that. Let's sketch the tangent where x is 2. So just type 2. Execute. Okay, now I pressed execute twice and you will notice that the equation of the tangent is there. So if this was an exam question and it just said find, you could do that on your calculator. You've got your equation of your tangent. If it was detailed reasoning, obviously you'd have to put all the working out and show that it ends up being 3x minus 5. Okay, now the reason that appears is because if I go to Shift and Setup and I scroll down, you can see this thing here, derivative, and if that is on, then that equation will appear. So I'm going to keep that on. Okay, let's see what happens. So I'm going to do the normal this time. So I'm going sketch, normal, and I want it where x is 2. So I enter 2 and I press execute a second time. At the minute, you can't see the equation of normal, so I press execute again. And there we've got it. So y is minus a third x plus 4/3, that would be. So let's just draw the tangent at the same time, just so you can see that. So and I press execute a second time, it gives me the equation. You can see, because we've got a nice square grid on the background, that they're perpendicular to each other. Okay, so that's fab. That gives us our answers straight away, using them for checking or for just getting your answers. Right, let's look at the next problem. So I'll exit and I'm going to delete that, and I need to differentiate e to the 0.2x. So I'm going to type in e to the 0.2 and then x, execute. Now, you know when you're in run mode, you can do differentiate at a particular point. So we're going to go options and calc, and we use the differentiate thing. Now, I can't be bothered to type that in again, so my shortcut is to type y1, and so whatever y1 was, e to the 0.2x, that's what's going in there. Okay, now normally you go in here and you have to type in a number, but if we put, x is equal to x, then when we draw, we've got the blue curve is the e to the 0.2x, and the red curve is its derivative. Now, if you differentiate e to the something x, you get something e to the something x. So I'm going to now type in what I think it should be. So I think it should be 0.2 and then e to the 0.2x. And if I draw that, hopefully my green line will exactly coincide with the red one. And that's a way of checking that I've got the right gradient function there. Okay, right. Finally, we've got number 3. The displacement of a particle is given by x is t sine t for t between 0 and 4. And we have to sketch the velocity time graph. So hopefully remember that if you differentiate displacement, you get velocity. dx by dt is velocity. So I'm going to, on the calculator, exit. I'm going to delete all this mess that I've got at the minute, except I'm going to keep the second one. The first one I'm going to type in, now I've got y equals, so I'm going to do x and then sine x. Okay, so don't worry, I've got y instead of x and I've got x instead of t, but that's fine. And then the next line I don't need to change because I want to differentiate the top line. So that's what it does. So let's execute. Now this will be a bit of a mess. Yep, that's a mess. So let's go view window, and I want to start from 0 and go up to 4. Okay, so let's execute that. That's a bit better. So now the blue curve is the displacement of the particle. That's the x equals t sine t. And the red one will be v is equal to, and that will be the velocity time graph. And you can see that, for example, where the blue curve is a minimum, where in this case x or t is 0, then the red curve has the y value of 0. Where the blue curve has a maximum, where t is 2, you can see the red curve, the gradient of that is 0. So that all corresponds. When the blue curve's going up, the red curve is positive. When the blue curve's going down, decreasing, the red curve is negative. So, and obviously I can go down a bit and I can see the rest of that. Okay, so that's one way of getting the velocity time graph. Now I could differentiate using the product rule and type that into my graph menu and see if it coincides, just like before, to check I've got it right.